we'll be discussing now fuel source for US electricity. 49% is for coal, 20% is by nuclear, and then 20% for natural gas, 7% hydroelectric, 1% is oil based, and 1% biomass, 1% is from wind. Okay. So for 49% coal, carbon capture and sequestration (CCS) with geological storage is key to the future of coal use for new power generation. 5 mm metric tons per year of carbon dioxide from one large unit. Okay, 20% nuclear has 90% capacity factor, and then 20% natural gas produces half the carbon dioxide of burning coal. 7% hydroelectric, which is 70% in northwest. Grand Coulee has 6,500 megawatt. 1% oil has greater than 90%, number 6 fuel oil, and 1% biomass, 65% forest products, 25% municipal solid waste, 5% agricultural waste, and 5% landfill methane. 1% wind has 30% capacity and miscellaneous source, geothermal, solar, etc. US will need 120 gigawatt of new supply and transmission by 2018. General nuclear plant hazard loss control. Okay, here is a list. So representative fire in nuclear plants back in 1997, country has Japan, and fire hazard, waste treatment process, and loss, no one knows how much. So nuclear power plant is always some hazardous. Whereas 1993 in India, lube oil and cable fire, that fire hazard created $20 million of loss. Whereas 1991, US has a lube oil, and then it created 2.5 million. So you can understand all these cases where you can have fire hazard. And if I talk about fire hazard, you have waste treatment process, lube oil and cable fire, lube oil, graphite and hydrogen explosion, cooling tower side, turbine lube oil, and then warehouse, construction site, cable fire, lube oil and cable fire, and 10 separate reactor, coolant pump, oil fires. Safety release emphasis, okay, you have redundancy, single failure criteria, separation criteria, cable criteria, and then you have radioactive contamination, you have ventilation and drainage. Here is a picture about pressurized water reactor PWR. Okay, that is we discussed previously, but here is a better picture now. So turbine generator, and then steam line, it goes there. Okay, so you have the containment structure. So ultimately, the steam actually heat up by this nuclear fusion or fission kind of technique, and that produce high vapor that goes to the turbine, it produces electricity. So this area containment structure, and this area we call pressure vessel. And then boiling water reactor BWR, okay, reactor building, okay, where you are seeing that the dry well and then reactor vessel, control rods and tool, you have the steam passes through there, steam line, it goes there, turbine generator, and then ultimately produce electricity. Whereas again, the cool down water, we bring it here, we try to heat up, and these are isolation valves. Okay, so these are reactor building area. Nuclear power plant hazard, pressurized water reactor containment, and you need to understand that you have you need to be knowing the description of ventilation and drainage. Fire hazard side, you have reactor, coolant pump, cable, air handling equipment, hydrogen, and fire protection, which has detection equipment, suppression equipment, and passive protection. Whereas PWR, auxiliary building, you have fire hazard, auxiliary feed water pumps, charging or makeup injection pump, you have hydrogen, air handling, switch gear or cables. And fire protection side, detection, suppression, passive protection. Boiling water reactor, BWR, containment, dry well, fire hazard. Okay, you have recirculating pumps and hydrogen. Fire protection, you have detection, suppression, dry well. Okay, inerting. Whereas boiling water reactor, containment, dry well. Okay, so the previous one, um, you have, okay, here we are starting with BWR reactor building. Okay, and you are seeing here fire hazard, HPCI turbine driven pumps, RCIC cable, MG sets, and location varies. And fire protection side, detection, suppression, and passive, and BWR off gas facilities. And fire hazard has hydrogen hazard, filter asbestos, okay, absorber, and ignition sources. Whereas fire protection side, you have hydrogen detection, system control, fire detection and suppression. Radioactive waste treatment side, you have fire hazard, okay, it has combustible storage, process hazard, and fire protection side, you have detection and suppressions are available. So these are a little bit of discussion about nuclear power plant hazard. Keep reading, there are plenty of discussions similar to that in the notes.